Hi everyone, my name is Li Baoyi. In this semester, I'm taking Computer Organization and Architecture as one of the courses in Section 1. In this video, I'm going to rerun Lab 2 involving arithmetic equation coding in assembly language. In order to run the lab, Microsoft Visual Studio 2010 is downloaded using VMware Workstation Player. In this lab, there are total 6 questions. By tracing and debugging tasks in Visual Studio, I managed to complete and submit Lab 2 while referring to the lectures and videos given in e-learning. Now, I'm going to rerun question 2 in Lab 2. First, open Microsoft Visual Studio 2010 in VMware Workstation Player. Next, click File, Open Project Solution. Select the solution file, name project. Then select Start Without Debugging, also equals to Ctrl plus F5. Select Step Over, represented by F10 in the keyboard. Watch window allows us to see the values of variables and expressions while debugging, and autos will show us every current values after each executing instruction. After each execution of each line, the value change will be represented by the red characters, such as in this, the red characters shown in Autos window. In line 1, move the value of xval, which is 26 in decimal, into register EAX. Next, in line 2, reverse the value of register EAX by converting it to its 2 complement, which is negative 26 in decimal. In line 3, move the value of yval, which is 30 in decimal, into register EBX. Here, we can observe that the content in register EBX is changed according to the value of yval. Next, in line 4, subtract the value of zval, which is 40 decimal in decimal, from register EBX. The value subtracted is stored in register EBX. Line 5 will add the value in register EBX into the value in register EAX. Store the value in register EAX. After line 6, add 1 into the value in register EAX. In line 7, which is the last instruction, move the value in register EAX into the variable of rval. Here ends the debugging of question 2. Next, I'm going to rerun question 4. The question is var4 equals to the value of var1 multiplied by 5 and divided by the value of var2 minus 3. Line 1 will move the value of var1, that is 40 in decimal number, into register AX. After line 2, move the value of 5 in decimal into register BX. In line 3, multiply the value in register BX, which is 5 in decimal number, with value in register AX. Store it in register AX. In line 4, move the value of var2, which is 10 in decimal number, into register BX. After line 5, 3 is subtracted from value in register BX. Line 6 will do the division by 8-bit operands. It divides the value in register AX, which is 200 in decimal, by the divisor, which is value in register BX, 7 in decimal number. And it can be shown that there is a register DX or the remainder value, which is represented by 0004 in hexadecimal, also equals to 4 in decimal number. While for AX, it is the value of quotient represented by 001C in hexadecimal, also equals to 28 in decimal number. Number is taken as quotient, which is 28. In the last line, line 7, move the value in register AX, which is the quotient, 28 decimal in decimal number, into var4. var4 will have the value of hexadecimal 001C. Here ends the debugging of question 4. After that, I'm going to rerun question 5. The question given A equals to the value B plus C multiply the value of D minus E. An assembly program is written. In line 1, move the value of val B, which is 12 in decimal, into register EAX. Line 2, move the value of val C, represented by 4 in decimal, into register EBX. Next, in line 3, add the value in register EBX with the value in register EAX. Store in register EAX. Line 4, move the value of var D, which is 20 in decimal, into register EBX. In line 5, subtract the value of var E, which is 10 in decimal, from the value in register EBX. Store the value in register EBX. Next, in line 6, multiplication using 32-bit operands. Multiply value in register EBX with the value in register EAX. Line 7, move the content in register EAX, which is 160 in decimal, into val A. Here ends the debugging of question 5. Next, in question 6, an assembly program is written to implement the following expression. A equals to the value of B divided by C multiply D. After start without debugging, line 1, move the value of 0 into register DX. This is to clear dividend. In line 2, move value of val B, which is 12 in decimal, into register AX. In line 3, move the value of val C, which is 4 in decimal, into the register BX. In line 4, divide the value in register AX by value in register BX. Store in register AX. In line 5, multiply the value in register AX, which is 3 in decimal, with the value of var D, which is 20 in decimal. Store the product value in register AX. Lastly, in line 6, Move the value of AX into val A, represented by 33C in hexadecimal, which is also 60 in decimal. This is the multiplication using 16-bit operands. Here ends the debugging of question 6. This is my reflection after completing Lab 2 exercise. In this lab, I learned how to run basic arithmetic equation using assembly coding, which is Microsoft Visual Studio in VMware Workstation Player. Thanks to the clear explanation and videos given by our lecturer, Encik Ahmad Faris. Besides that, to organize the task and time well, also, I have learned to be more careful and conscious during the debugging and tracing process to minimize the errors and to speed up the debugging process.